Hey there! In this video I'll be completing the development of the Playground app for Android. We've made great strides by setting up the Flutter app and defining the Rust API for our backend. Crafting the Rust code involved leveraging various IOTA libraries simultaneously. To ensure robustness, we manually cross-compiled the API code for different target platforms, uncovering issues where they exist. As a result, our code is operational for the majority of targets. So what remains to be done? Well, in this video we'll integrate cross-compilation into the Android build process. After that, using the Flutter-Rust-Bridge, we'll generate Dart code for our API and incorporate Dart code to load the cross-compiled library. Then we are almost there. The user interface needs adjustment, meaning the API needs to be called. Finally, we launch the app and see if it works. Our manually built library is currently in Rust's target folder. But that's not where it should be, and we are going to change that. First, go ahead and install Cargo NDK. In the Android build Gradle file, there's a minor error that we can quickly address. Now, the more important task at hand is to expand the build process. We want to automate the execution of Cargo build and ensure that the resulting library is copied to the correct destination within the Android directory. The next key step is generating the Dart code for the API. And for that, I'm utilizing the code generator from the Flutter-Rust-Bridge. I'll copy this command and execute it. As a result, several generated files will appear in the Rust directory. In my experience, VS Code might flag them as erroneous. I haven't identified the reason, but restarting VS Code tends to make those errors disappear. Next, in the lib directory, so the Dart directory, I create a new file named ffi-dart and paste the code for loading the library into it. Here's a task for you. Modify the Dart code from the examples to incorporate the API. In the tutorial, you'll find the code that needs to be replaced. It would be incredibly tedious if I demonstrated here in the video how I replace all the code places. This effort isn't exclusive to Android. You're also setting the stage for macOS and iOS. Now let's give everything a go on Android. Ensure that the Android emulator is active and then run the command flutter run. After some time, the app launches on the emulator. Go ahead and inspect the first example. Here's the snag. The indicator keeps spinning, but the backend isn't providing a result. The issue lies in the fact that our library isn't loaded. Refer to the tutorial for additional information on this and how to resolve it. In this case, it's necessary to download the libc++ shared library and place it in the same location as our librust library, specifically in the subfolder JNI-libs. Now let's run the app again. Well, I can reveal that all the examples now function as intended. If you are testing the app yourself, make sure to run the examples from top to bottom, as some of them are interdependent. Have fun! The wallet example remains noteworthy as it allows you to inspect the Android emulator's file system and confirm the creation of the RocksDB database and the Stronghold snapshot file.
Turn the world around. Turn